I know I'm in the doghouse somewhat with you, my channel audience, and wearing green is quite the risk. I ensured the car was the right colour though, but more of that later. Let's first head to the yard. Yes, Alan's original yard, where I'm still a source of amusement to the ever-patient team who run it. First of all, apologies about my garb. I'm about to go for a run, and that's the only reason why there's no glass of wine on the table. Anyway, I told you a few episodes ago that I was planning to do some CAD work, because it should be, if you're good at it, quicker, it can be precise, it's just obviously how things are done these days. CAD's been around for a while. But I wasn't really aware of the sheer learning curve that was going to be ahead of me. And I've become pretty damn good over the years of using Photoshop. I mean, I was using Photoshop back from long since when it wasn't a subscription. It was, you actually paid for it before even the days of the Creative Suite, if you remember CS and CS2 and all that sort of stuff. So I've been using this since I was a teenager, and it's just like a language, you get to know it. CAD is also a language, and it's one that I am not fluent in, and I'm unlikely to get fluent in. So I've decided this is the moment at which I decide I'm not going to try and learn how to do everything. I'm a real fan when I'm doing projects to try and become at least partially aware of how most things work. That's why I do a lot of things DIY, and I don't just farm everything out to other people. But there's a point at which I am going to just be burning up hours and hours of work trying to learn how to use this damn software. And I'm sure it's perfectly good software. It's called Shaper 3D or something, and there are other ones too, I know. But look, I'm going to do things my way, which is going to be sketching up what I think things should look like, and I'm going to do all my dimensions and do everything properly to scale. But then I'm literally going to take a photograph, send it to someone who knows how to do CAD far, far faster and better than I can, and then hours later I'll get the files back, pay a few quid, job done. That's what I'm going to do. So apologies to CAD aficionados out there. I'm going to be denying you the indulgence of watching me do it horrendously badly and getting frustrated. And I'm going to concentrate on what I'm good at. I need to make some precise shapes so that I can make the scale model, which is going to be the prototype for Bernard. I sketched out the shapes, dimensions and curve types, and then sent them to a rather efficient man in Singapore who provided my DXF and PDF files within the day, and for roughly the price of a beer per drawing. I like this plan. What you see me placing down on the table are the fruits of that decision to outsource. And yes, that's the original table I've always used at the yard. I'll resurface and re-orange it soon. These are the professionally cut horizontal MDF guides I intend to position soon, interspersed with rigid foam, to form the pattern for a scale model of my first vehicle shell. I'm making some copies of the uniform section, since the CNC machine cut ones were quite expensive. I also did some cutting of my own, and the edge off cuts illustrate the failure mode of form cord sheet, a diagonal crack in the foam through shear, and perfectly serviceable top and bottom laminates in effect sliding alongside each other. I'll show you the test results on the main piece at the end. Oh, and I had a go with generative AI logos. This was from 2 basic sentences of instructions I gave Google Gemini, and no, Bernard will not look like this. I was just having a play. That said, the first attempts can only be described as Bernard, and so I changed my request to cartoon style and not photorealistic. In a supremely coherent narrative thread, I'm now showing you a view of Gunwharf Quays on an overcast morning. It's actually more interesting than you'd think, as that red ship is of note. It's a special ice-rated luxury touring ship for very, very rich people who like to travel on seas that contain cold, solidified water. Back to my random voyage of the day. This is a camber area containing much history, and there beyond is the entrance to mighty Portsmouth Harbour. I was on a small-ish car ferry, and was enjoying how my fellow seafarers had complied with the request to disable car alarms.
Emergencies happen very rarely.
Anyhow, we made it out the harbour, past all the old fortifications that date in part back to the 15th century, and past some more of the 19th century forts that were built as we feared Napoleon's nephew was going to have another crack at taking over Europe. Anyhow, I also enjoyed the fact that this barge can float. There's a certain spirit I respected in this vessel, nonchalantly comfortable in its own skin, just going about its day without a fuss. This yacht got in the way of our turn to the south, and then all of a sudden we were on the Isle of Wight. I found a 1,000-year-old castle, but then got to work. I'm just arriving into Gurit, which I gather is how you pronounce it, and they're very kindly giving me some carbon fibre, some glass fibre, and also some resin. I think maybe some core as well. This is one of many kind gestures by members of this YouTube army we've somehow cobbled together since those heady days of 2020. These guys really, really know their composites, the wider industry which for a number of reasons has a strong showing on the island, and one of their many areas of expertise are high-performance boats. This is a mock-up of a typical carbon hull layup should you have a rather healthy budget. It was a quiet Friday at the facility, some of which is for storage, other areas for research and testing, others for packing orders, and some for manufacturing and curing. I was particularly taken with this glass fibre weaving machine, a loom I suppose. I wouldn't want to be the person responsible for placing one of the toes through the wrong gap or hole, and so making a wonky sheet of woven cloth. Gurit do supply raw materials and products to business customers and the public who make their own stuff, but they also design, test and manufacture cutting-edge custom parts. They know how to integrate foam core to composites better than anyone, which is useful given Bernard's needs, and separately, this solid carbon cross-section probably cost hundreds of pounds purely in materials. Amazing work. Anyhow, the upshot of my mini holiday was to collect a couple of 100 kilos of decertified or otherwise unwanted biaxial carbon fibre, some Integra, 2,2 twill carbon, and even some Kevlar. It turned out that my very presence had perked the weather up, and so the trip back the same day was rather better. They didn't even check my ticket, so I managed to jump on the ferry an hour earlier than booked. It's not a long way, and perhaps it was slightly different waves, but the motion wasn't setting the cars off quite so much. I'm imagining this view, but instead it being the starboard bow section of the mighty vehicle Bernard, at some future date towed or motoring across calm waters. Very agreeable. I was quite disappointed the barge hadn't stuck around and the passenger ferry was boring, so I went in search of Alan's cousin, since surely all ships have them. This was the nearest thing I could find. Sort of an Alan, but in a more sporty mood. Here's a better view of one of those defensive forts that's now privately owned. The view of Southsea seafront and the War Memorial, and then back to the harbour. The Isle of Wight ferry port you get to first, and then the huge Royal Navy dockyard lies further back, beside the commercial and larger ferry docks. The reason I'm lingering on these scenes is because this is where I grew up. I won't say where, obviously, but one of these clips shows my childhood home. I checked that billionaire's Alan was still safely moored in the comically expensive marina, and commented under my breath about how it would look much better coloured a proper Alan orange, which by the way is RAL 2010 Signal Orange. Somehow the carbon fibre survived, and I didn't spark a major incident for travelling with lots of epoxy resin in the car. And guess where the fabrics are now to be safely stored for the time being? Of course, you guessed it. That wonderful facility not far from me in London, where humidity and temperature is wonderfully stable, and whose services I most certainly do not brazenly shoehorn into every available opportunity in my episodes. Cheers for also thinking that they are as wondrous as I do, and to those of you in southern England who would rather set light to all their worldly goods in a pagan sacrifice to the YouTube gods than consider any storage facility other than Vanguard. Well, that was daft. So back to the promised laminate sandwich testing. You'll recall that I hop and jump tested a small plank of carbon and Integra with a PVC foam core recently. I've updated the recipe and used the hex pattern PET core, made it larger, and solidly screwed down the two sides so that those areas can't slide inward under deflection. The only thing I'd not thought of at the time I did the layup was lots of tongues of resin and fabric running through the core, binding the bread slices of our sandwich together. Anyhow, I even printed off a little custom ruler for this very purpose and made it stand up. You can thank me in the comments, or in person should you wish, but the comment section is safer for us both. We can see here that the bottom ply of carbon is at 75mm. Oh, and more on the new sandwich. I was ambitious and tried to go a little lighter, and hoped the intentional curve in the sheet would help resist deflection. It's a total of 1,600 GSM of fabrics, a 50-50 ratio of epoxy resin, which you can manage even with wet lay if you're not using too much thick woven cloth, which tends to have more voids in. Here's what I mean. Woven at the top. Due to all the wiggling and crimping, you end up with gaps you need resin to fill. Impregnated unidirectional cloth at the bottom there lies together more closely and so have fewer empty voids that end up needing to be resin filled. Here's the reduction in required resin. Thinner, lighter, cheaper, stronger, but the layers wick resin through from ply to ply more slowly so it can be slower to wet out. A rough and ready diagram, but you get the idea. My sandwich was mainly carbon in 0, 90, 45 and minus 45 orientation, so there's torsional stiffness and not just front to back and side to side. There's a toughening layer of 300 GSM diolen this time, not 120 GSM Integra, in the middle of both plies, and I was intrigued about a top layer of 400 GSM S-glass. I'm wondering if, despite the weight, a layer of this special high tensile strength glass on the top, or outside, could benefit impact protection as it's stretchier than carbon, ease of repair, and it's also perhaps easier to sand to an outer finish if we choose to forego a gel coat. The core is still 10mm. Let's do it. I started cautiously, but I didn't want to break it by accident from the word go, but there's a little flex there as the curve flattens out, down about 10mm in the centre. Finally, all my weight in the middle, and we're down nearly another 5mm, so there's now a slight downward bowing, no longer flat. I kinda knew it, but this sheet really is too lightweight. But amazingly, this would end up, if made to a full-size vehicle shell of roughly 2 meters by 5 meters, weighing less than 100 kilos. That's seriously light. And it's only 13 millimeters thick, so that's 1.5 millimeters of fibre each side of the core. For reference, Alan's solid lower hull was at least 10 millimeters thick. No matter about the what-ifs though, it's time to go on one foot to increase the point pressure. No major change. But then to hopping, we get around a further 5 millimeter downward flexing at the centre point. That actually kept working fine with each hop, and there was no noise, and that means that neither fibre nor resin was being damaged, and not even the fragile foam either. Jump number 1. It didn't really bow down much further than the static hops. Let's go for another one. Less successful. You can see the moment of linear failure where the foam cracks, stops keeping the two plies of carbon properly orientated, and so they flex too much, the foam rips away, and it's toast. Unsurprisingly, since each composite sheet can bend back practically into a U-shape, there's no damage to the carbon matrix itself, but all the load-bearing ability is gone. The solution is fairly straightforward. I must link top and bottom plies through the core, probably with carbon fibre strips due to its interlaminar and tensile strength, the two key characteristics we need for that job. Also making both sides thicker, and making a decision about whether the toughening layer will be a Negra or diolen. I could increase the quantity of material by 40% and still have a lightweight shell. I'll also do away with the S-glass. It's impressive stuff, but doesn't offer the benefits the weight penalty would necessitate. Carbon is more hydrophobic and so better in the event of damage and a patch repair. S-glass is only a bit higher in tensile strength, but is 40% denser. S-glass is 3 times stretchier than carbon, but it's at the back or the bottom of the laminate that's being in our case asked to stretch under load or impact. Enough of that now. I'm busy setting up the sodium battery investigation and building that scale model. Bye.